Hello everyone. So here we are going to start a new series of NCERT book in which in this video we are going to study the part 1 of NCERT book physics, and the topic name is electric charge and fields. So in this video we will only discuss about the formulas and important concepts, and on the basis of which we will do the problems of NCERT exercises in the next video. Okay, so if you like my video and content, then you can comment below so that I can make a detailed video. If you want the detailed explanation of this topic, then I will provide that later. Okay, so before moving to this topic, we will see that what is types of body. Okay, so there are three type of body. One is neutral body, in which as we know that any body contain electron and proton. Okay, so so if the number of electron is equal to the number of proton, that means it is a neutral body. Its total net or Q net is 0. Now if we give excess electron to the neutral body, then we get a negatively charged body in which number of electron is more than number of proton. That's why Q net is negative here. Okay, so now if we extract some electron from the neutral body, then we get the positively charged body in which number of proton is more than the number of electron. So here Q net will be positive. So here are some important facts of or characteristics of charge. So its SI unit is coulomb, is represented by the capital C. So smallest unit of charge is ESU or Franklin. Okay, ESU means what? Now electrostatic unit. Okay, so its largest unit is Faraday. Now it is additive in nature. If in a system we have Q1, Q2 and Q3 charge, now the net charge what will be the net charge? Net charge will be the mathematical summation of all these three charges. That means Q1 plus Q2 plus Q3. Okay, so it is additive in nature. That's why. So it is conservative. It always the conservation means it is conservative in nature. It is never created. Charges can be never created, can never destroyed. It only transfer from one body to another body. Like here we already know that the electron will move from neutral body, um, then we will get the positively charged body. If the electron if we give electron to a neutral body, then we will get the negatively charged body. So here electron is moving from one body to another body, so we are not creating electron here. Okay, so this is conservative. So it always quantization means Q is plus or minus NE. Okay, N stands for integer here. So we are transforming the electron in the form of a whole number. Okay, so we cannot transfer electron in fractional or decimal form. Okay, we have to transfer electron in a whole number basis. So what is the smallest charge? Smallest charge, if we put n is 1, then we will get plus or minus e. Now its value is 1.6 into 10 to the power minus 19 coulomb. Okay, plus or minus. So the charge of an electron will be minus 1.6 into 10 to the power minus 19 coulomb, and the charge of a proton will be plus 1.6 into 10 to the power minus 19 coulomb. Okay, now the same charge repel each other and opposite charge attract each other. If there is if in a system there is two positive charges, they will repel each other, or if there will be two negative charges, they will also repel each other. But if in a system we have one positive and one negative, they will attract each other. So this force is known as Coulomb force. Okay, the force acting in between these charges, positive positive, negative positive, or negative negative, is known as Coulombic force. We will discuss about the latter. Now charge is invariant, it does not depend on speed. Okay, now if there is a charge Q and it will move with a velocity v, it will remain that charge Q, it will not change. Okay, but if we say that object, if we say about an object O will move with a velocity v, then its mass will what increases. Okay, as we increase the velocity, the mass is also increases, mass of an object. So but charge is invariant with the speed. If speed changes, then it has no impact on the charge. So charge cannot exist without mass, but mass can exist without charge. For example, neutral body, okay, that has mass but has no charge. Okay, but each charge have some mass. So what about the specific charge? So specific charge formula is Q by M. So as we can see here that as we increase the speed, then the mass is increases, so that the specific charge is decreases here. So it depends on the speed. So how can we charge a body? there are three ways of charging a body: conduction, induction, and friction. So in case of conduction, we put two body together in a direct contact. Okay, so here let's imagine this is a negatively charged body and this is the neutral body in contact. The charges from the negatively charged body will transfer from the negatively charged body to the neutral body to make this neutral body a charged one. Okay, so in this way this neutral body will be charged. So in case of conduction without contact, okay, so here let us consider this is a negatively charged body and this is a neutral body, which we move. This neutral body is moved towards the negatively charged body and they are not in contact. We just put them some distance apart. So what will happen, so this is the negatively charged body. Okay, so what will happen in this material? So every material has some proton and electron, okay, positive charge and negative charges. Okay, so they are distributed like this. Okay, but when we move a negatively charged body towards it, what will happen to it in the next step? So this is a negatively charged and these bodies, the distribution will be in this type ki positive charges will move towards this end and negative charge will move towards this end, because positive charge is attracted by the negative charge. Okay, so this phase will contribute the positive charge and this phase will contribute the negative charge. So this separation of positive negative charge is known as polarization. Okay, so here positive charge induced, okay, positive charge induced in this material due to this negative body. So another way is friction. Okay, so when we rub two body, so thermal energy created here. Okay, so from the thermal energy, what will happen when we rub one body with the other? So the outermost electron, okay, the outermost electron will travel to the next or the other body. Okay, so in this way both body get charged. Now what do we mean by charge transfer? When we transfer the charge in this three process, that means there is some mass is also transforming. Okay, so as we know that charge have some mass, so as the charge moves, mass is also moves because mass is associated with the charge. Okay, so what is the mass of electron? This is 9.1 into 10 to the power minus 31 kg, and mass of proton is 1.6 into 10 to the power minus 27 kg, and their charge is mentioned like this. Okay, so what is Coulomb's law? We already explained that when two charges come together in a system, they will experience some force. Okay, now that force is known as Coulombic force. They will feel some force of attraction or force of repulsion. That force is known as force of Coulombic force. Okay, so this Coulombic force is directly proportional to the product of the two charges, inversely proportional to the square of the distance between them, and it also depends on the medium. Hello. Okay, now the final formula will be F is equal to K Q1 Q2 by R square. Now what is K here? K is 1 by 4 pi epsilon naught. It is a constant. Okay, so epsilon naught is the permittivity of the free space, and 1 by 4 pi epsilon naught, it has the value 9 into 10 to the power 9, and its unit is in Newton meter square per Coulomb square. Now if we plot a graph between F and R, we get like this because it is exponential, so this is like this. Okay, so what do you mean by permittivity? Permittivity is the ability of a material which permit electric field lines to pass through it. Okay, so this is a material, so it is the material's ability to permit electric field. Okay, permit electric field to pass through it. So epsilon naught is the permittivity of the free space, epsilon m is the permittivity of the medium, and epsilon r is the relative permittivity. So we have a relationship between these three. So epsilon r is epsilon m by epsilon naught. Okay, so how can we find the permittivity of any medium? Okay, so it is the multiplication of epsilon r into epsilon naught. So epsilon m is epsilon r times epsilon naught. Okay, it sounds some confusing type, but it is so simple. Epsilon m is equal to relative permittivity times permittivity of the free space, but in case of force it is inversely proportional to epsilon. Okay, so that's why the force of the medium will be epsilon r times decreases. Okay, as it is inversely proportional to the epsilon naught or permittivity, so it decreases, forces decreases as I introduce any medium here. Okay, so what do you mean by superposition principle? So here is a charge, okay, q1. Okay, so there are also many charges in that particular system. Okay, so each charge will have some impact on this q1 charge. So if we add all those effect or all those forces, then we can get the net force on the q1 due to other charges. Okay, so like this, f1 is f12 মানে f1 force on 1 due to 2 plus force on 1 due to 3, force on 1 due to 4, up to force on 1 due to nth charge. Okay, so if we combine this, we will get this resultant force. Now what do you mean by electric field? Electric field means what? If we have a charge here, now it will have some effect around it. Okay, if we have a positive charge, the electric field direction is radially outward and it can go to infinity, but the strength is decreases as we increase the distance from this point charge. Okay, if we have negative charge, then the direction will be radially inwards. Okay, so it can also come from the infinity, but the density is increased here. Density is more here than infinity. Okay, so this is the thing, and the formula of electric field is kq by r square. Okay, and it has the direction along r. So its unit is Newton by Coulomb. So the relationship between F and E is F is equal to QE. As we know that if we consider that there is a uniform electric field. Okay, what do you mean by uniform electric field? Uniform electric field is equidistanced, equispaced. Okay, now uniform throughout the system. Okay, so if we put a charge here, in the uniform electric field, so what will happen to the charge? It will experience some force. Okay, and how much force it will experience? It will experience the force of QE. Okay, this much force this charge will experience here. So from here electric field is equal to F by Q. So F unit is Newton and Q is Coulomb, that's why Newton per Coulomb. Okay, now superposition principle. So it is like the force superposition principle. So it is the summation of all nth charges or on nth electric field due to nth particle or nth charge. So it is k into whole into q1 by r1 square plus up to qn by rn square. Okay, so lines of force. So there are some characteristics of the lines of force. So it starts from positive charge and ends at the negative charge. Okay, for a single charge it may start and end at infinity, as we already I already shown or explained here ki these electric field lines, they radially outward or outward from the positive charge and radially inward towards the negative charge, and it can start from negative in case of negatively point charge, and it can end at the infinity. In case of positive charge. Okay, so here, and the lines of force starts from positive and ends at negative. This is positive charge, this is negative charge. It can start and end here. Okay, like this. All right, so two field lines never cross each other. Okay, two field lines, they will never cross each other because one point cannot have two direction. Now how can we find a direction of a electric field? Now just find the tangent at that point of the electric field, you can find the direction. So as we see that if two electric field are cross each other, then they will intersect at this point. Okay, so this point is also the point on one electric field, and this is also a point on the second electric field. And if we find the direction of this point according to the second electric field, it will indicate towards this. Okay, now if we need to find the direction of this point according to first electric field, it will direct like this. Okay, so one point cannot have two directions, so that's why they never cross each other. Okay, now they do not form any closed loop. Okay, they do not form any closed loop. They only start from here and end at here. It is continuous, never breaks. Okay, this line of force never breaks, only continuous, and they do not form any closed loop. Line of force cannot like this. Okay, cannot form like this. So this is continuous. Okay, they cannot discontinue, and they are directly proportional to the magnitude of the charge and area. What do you mean by this? The electric field line directly proportional to the charge. If we have q charge here and if we have 2q charge here, so whose magnitude is more? 2q, right? So this will emit more electric field than q charge. Okay, so if q charge emit 4, okay, 4 line of force, 2q charge will emit 8 line of force. Okay, 8 line of force. So the line of force directly proportional to the magnitude of the charge. More charge, more line of force. Now area, if we have a plane surface this, so line of force moving like this. So here flux is 3, okay, because 3 line of force passes from this plane. Okay, now if we take a larger area, this, so more line of force will pass through this. Okay, so here how much flux is? So 1 2 3 4 5 6 7, so there are 7 line of force passed from this surface larger area. So also line of force directly proportional to the area and magnitude of the charges. Okay, clear? Now by describing it, I took a word, that is flux. What is flux? Electric flux. It is that electric line of force, okay, that we know that flux, how much electric line of force passes from a particular surface, okay, a particular surface, so that is the flux. So its formula is E dot ds, E dot del s. Okay, this is the dot product. Now it is the cos theta. Theta is the angle between electric field and the areal vector. If we take this is at the what surface, then its area vector is perpendicular to the surface. Okay, area vector will always perpendicular to the surface. Now if its direction, area direction is this, in this direction, and electric field direction is this, now theta is 0 here. Okay, theta is 0 in this case. In this case, now if we take that this is the surface and electric field line will pass like this, electric field, and its areal vector direction is upward. Okay, normal towards the surface. Okay, normal towards the surface. Now here what is the theta? It is 90. Okay, so it is 90 means no flux is there. Okay, not a single electric line of force will pass through the surface when we put it perpendicular to the direction of the electric field. If electric field direction is in this direction and we put a surface which is perpendicular to it, okay, perpendicular to it, now it will exhibit 0 flux through this surface. Okay, now if meanwhile if the direction is along the electric field lines, then it will exhibit more number of flux. Okay, more number of electric field will pass through this surface. Okay, all right, so we already say that it depends on the theta. Okay, whether it will be maximum or minimum flux, it will depend on the value of theta. Its unit is in Newton meter square per coulomb. Okay, now come towards the electric dipole. So dipole is what? It is the pair of equal and opposite charges. This is a dipole and we have an equal pair and opposite charges. This is q and this is minus q, or this is 2q or this is minus 2q, equal but opposite charges pair. Okay, so this is 3q or this is minus 3q. So this is the pair of equal and opposite charges. This we know that electric dipole. So they are kept at a distance of 2a. Let us imagine they are kept at a distance of 2a, and its direction will be from minus q to plus q. So here is another interesting fact, that electric field has the direction from plus charge to the negative charge. Okay, so we already say na ki plus q will exhibit the radially outward electric field and negative charge will exhibit radially inward electric field. So the direction will be from positive charge to negative charge electric field. Okay, but in case of dipole it is opposite to the electric field. The direction will be minus q to plus q. Hence the total charge inside it, how much? Q net is 0, because positive q minus q is 0 plus 2q minus 2q is 0. So the dipole P will be q into 2a. This is the electric dipole formula. Now there have 3 cases. Okay, 3 cases means what? So this is a dipole, this is plus q, this is minus q. What if we place a charge on the axis of the dipole, on the axis of the dipole? What will happen to this dipole? So what is the electric field at this point? What is the electric field at this point? Okay, so electric field will be what? Not 2 kp by r cube. What is r? r is the distance from the center of the dipole. It is the center of the dipole to the point on the axis. Okay, so this is the dipole having 2a distance between them, and this is a point. We need to find the electric field at this point. Okay, so which is at the distance of r from the center of the dipole. All right, now this point exhibit electric field in this direction due to minus q, because it is minus q. We have to also keep in mind that any point we take, we should take it as a test charge. Okay, and test charge is q naught, which is very small in number, so only we keep in mind that it is positive. Okay, it is very small in number, that's why it has no that much impact on the dipole, but we need to find the electric field at this point, so we put this as a positive charge, and if it is positive, now the negative charge will attract it, so eq direction will be like this and e plus q direction will be like this, because it repel. Okay, so what is the net? It will 2kp by rq. Now if you need to find the detailed explanation of this, you can comment me below. I will explain it in the later videos. Okay, so in the equilateral plane, what is the formula? It is minus kp by rq. So the diagram will be like this. This is the dipole. Okay, plus q minus q, there is a 2a distance between them, and a point charge is kept at the r distance from the dipole, from the center of the dipole in the perpendicular direction. Okay, now it will experience e minus q in this direction due to it is the negative charge and it is the positive charge, they will attract. Okay, now it will repel in this direction. Okay, due to this, now the resultant will be e perpendicular this. Now this electric field has the magnitude minus kp by rq. Okay, so what if we calculate for any arbitrary point? Okay, any arbitrary point. This is a dipole plus q minus q. Now we need to find that any arbitrary point, we need to find the electric field at any arbitrary point. Now the formula will be like this: kp by r cube, 1 plus 3 cos square theta root over. Okay, you have to remember it, no other options left here. Now come to the torque. So what do you mean by torque? So if we place a dipole, in a uniform electric field, okay, here we place a dipole in an uniform electric field. What do you mean by uniform? It is straight, equispaced and parallel lines of force. Okay, so what will happen? This electric field will experience some torque. Okay, so its value will be P cross E. It is cross. Okay, it has direction. The P is sine theta. The theta is the direction or angle between the electric field and the dipole moment. Okay, so as we can see in this case, that the electric field direction is this and dipole direction is this, and theta will be 0. So sine theta is 0, so here torque will be 0. That means the dipole will never try to bend itself. Okay, so we need to take another example. So here is a electric field. Okay, now we put a dipole like this. This is minus q and this is plus q. Now what will happen here? This is electric field. Okay, so dipole moment direction will be from minus q to plus q, right? So here is dipole moment, here is electric field, so this is the theta. So this dipole will try to bend itself in the direction of electric field. Okay, this dipole will try to bend itself in the direction of electric field. So it will do some work to align itself in the direction of electric field. Okay, so this work, okay, so this tilt is known as torque. This will experience some force. This dipole will experience some force due to this electric field, that is P cross E. So this is the theta. Okay, now if we see what, now this is our electric field and the dipole moment is like this. Stays perpendicular to the electric field. Okay, so this is minus q and this is plus q. The dipole moment direction is in this direction. Okay, upward. Now the theta will be what? 90 degree. So it will exhibit the maximum torque. It will experience maximum torque. Okay, that's why it will exhibit maximum torque, so that it can align easily in the direction of the electric field. In this universe, everyone wants to stay in the equilibrium position, in the rest position. Okay, no external force on any object. Okay, they will need this. So if our dipole is like this, then it will also like want that uh, it will also want to gain that equilibrium position as well. Okay, so this is the concept of torque. Okay, hope you all understand this. So what will happen to the next, it is about the charge distribution. So if the charge distribution is continuous, not discontinuous, okay, we are considering continuous. Now if the charge distribution is continuous and surface charge density, surface charge density is represented as sigma, so this is q by area. Okay, surface means we take its area, and linear means we take its length. Okay, in that length of the rod or length of the system, how much charge is distributed continuously. Okay, that is known as linear charge density, the q by length. Okay, so charge per unit length is given to lambda, or charge per unit area will give us the surface charge density, and charge per unit volume will give us volume charge density, that is rho. Okay, now move towards the Gauss law. So Gauss law is nothing but about the electric flux. Okay, so this is the Gaussian surface. Okay, so q is the net charge enclosed within that Gaussian surface. Now what is the net flux enclosed, what is the net flux which will pass through this surface, this Gaussian surface, due to this charge? It will q by epsilon naught. Q means what? The total charge enclosed within that Gaussian surface. I repeat, the total charge enclosed within that Gaussian surface per epsilon naught. Okay, so this is what the electric flux. Okay, so in order to find the electric flux, we should take the Gaussian surface as closed, and it should be 3D, and the electric field should be uniform. Okay, so that only in that case we can apply this formula. All right, now we can also derive this Gauss law from this formula, that delta phi is E dot delta S. So from this we can also find out this. Okay, now what are the applications of Gauss law? So there are many applications of the Gauss law, but in the NCERT book we only describe about the 3. If you need the detailed explanation of it, you can comment me below. I will explain it in the later videos. Okay, so what are the applications? The first, infinitely long straight uniformly charged wire. Okay, so this is a infinite long straight uniformly charged wire. Okay, it is infinite, and in case of a rod, what is the Gaussian surface we can make? The Gaussian surface will be in the form of a cylinder, because they all are at the equal distance from this rod. Okay, as we can see, this is at the r distance, this is at the r distance. Okay, so they all are equal distance in this direction also, in this direction also. Okay, so in case of a point charge, the Gaussian surface will be a sphere. Okay, every point is same, like r, capital R, the radius. Okay, so this is the Gaussian surface. So we need to also have we should have the idea that what is the Gaussian surface about any kind of body. So it will develop, so this idea will develop eventually after we practicing so much questions. Okay, so like in case of long straight wire, the Gaussian surface is cylinder type. In case of point charge, the Gaussian surface is spherical type. Okay, so okay, leave all those things. So Gauss law application about the infinitely long straight infinite charged wire, the electric field will be lambda by 2 pi epsilon naught into r. So this is the electric field, about the electric field of the infinitely long wire. Okay, now in case of infinite plane sheet, okay, now this plane is infinite, so what is the electric field, how much flux will cross towards the surface of from the surface of this plane sheet? So the electric field is sigma by 2 epsilon naught. Okay, sigma by 2 epsilon naught. So this is the electric field of the plane sheet. Okay, now the uniformly charged thin spherical shell. Okay, thin spherical shell. So in case of a thin spherical shell, we have a Gaussian surface like this. Okay, this is the Gaussian surface above it. So this is the thin spherical sphere. So we have a point here on the Gaussian surface. Okay, now we need to find the electric field inside the spherical cell. So electric field inside the spherical cell is 0, and outside of the spherical cell it is kq by r square. Okay, r is the distance from the center of the spherical cell to the point. Okay, to the point where we need to find the electric field. All right, now why this is 0? Because it will take another class also. This is a long process. Sphere has of two type. One is conducting, another one is non-conducting type. So thin spherical cell, hollow, and solid sphere. Okay, hollow sphere and solid sphere. So in case of hollow sphere, there is two type. One is conducting, another one is non-conducting. Similarly, in case of solid, one is conducting, another one is non-conducting, and this non-conducting we call it as what? Dielectrics. So leave that. So in case of conducting and non-conducting, hollow sphere, or conducting solid sphere. Okay, so these all exhibit E inside is 0, because they have no charge inside the sphere, because every charge is distributed on the surface of the sphere. Inside them there is no charge. That's why, according to the Gauss law, that it is the total charge enclosed within the surface. Okay, so if there is no charge, there is no flux, no electric field. So that's why inside is 0. Okay, but the exception case is non-conducting solid sphere. So we need to stop here, because NCERT syllabus is limited for here. Okay, so in the next video we will discuss about the NCERT problems or exercise problems. Okay, so if you need the detailed videos of these things, how the formula we get, so you can comment me below. Okay, thank you so much for listening.